Hey everyone, this is Bobby Harris, the Executive Director of the Utility Broadband Alliance. It's my pleasure to welcome you here today for a wonderful webinar. We are going to just pause a moment, let everybody get logged in. I know sometimes it takes a moment when we're right at the top of the hour for everyone's systems to kick in, and I don't want anyone to miss a moment of this important webinar. For those of you who are on the phone, obviously you heard the recording say you're in listen only mode, but you can use the question tool. If you're new to this tool, it should be in your little toolbox. There's a drop down that says questions. You'll type your questions for the panel in there exactly as you would like them read, because we will read them exactly at the end. We will do our very best to get to everyone's questions. Of course, if we run out of time, our panelists will follow up with you individually after the webinar, so no worries there. Sometimes we get an overabundance of great questions, so we'll do our best to get to everyone. In the short term, it looks like we're getting everybody logged in. Again, I'm Bobby Harris from UBBA. For those of you who don't know, we have the Utility Broadband Alliance Summit and Plug Fest coming up November 4th through the 6th in Charlotte, North Carolina. We do still have a few tickets available. If you haven't registered yet, get registered. Our hotel room block is sold out, but you know, there's still great prices around and multiple hotels around the Westin in Charlotte. So please let us know if you have any questions or challenges there. And, you know, without further ado, I'm very pleased for this webinar, not only because we have one of our great founding members in Nokia leading the way, but we also have all of our other great members on this webinar. Just some really top-notch guys that are going to share their knowledge. We are kicking off an initiative around AMI 2.0. We've been working with utilities for about a year and a half. We'll have a major workshop at the Summit and Plug Fest, and then ongoing initiatives all through next year. This is a wonderful way to kick that off. Hemant, I'm so thankful for you and Nokia for leading the charge here, for Jeremy and Jan and Amanye and Ron Brady for being on today's webinar. I'm going to stop talking because these folks did not come on to hear me, and I'm turning it over to you right now, sir. Take it away.
Thank you, Bobby. Yeah, first of all, a sincere thank you to UBBA and to all the members who have joined on our webinar today. So on behalf of Nokia, I would also like to extend a special note of gratitude to you, Bobby, for making this platform available for us to discuss an important topic related to AMI 2.0, which is leveraging today's LTE maturity while we are preparing for future evolutions for the utilities. So as Bobby mentioned, so I am Hemant Rilan. I am the Radio Solution Manager at Nokia, and I'll be moderating this important session. And I am joined by a truly distinguished panel of experts, Ron Brady, who works as a Senior Network Architect at Excel Energy, Jan Forslo, who works as a Solution Architect at Itron, Abhinay Sinai, who is the Director of Technology at Interix, and Jeremy, who leads the product marketing at Sequans. We are all excited to share our insights and perspectives with you on this important topic. With AMI 2.0 and the rapid evolution of cellular technology, utilities face a critical balancing act, which is embracing the proven maturity of current solutions while we prepare for what comes next. The central theme of our webinar is finding the right trade-offs between maturity and the future readiness. We aim to show you how to maximize today's capabilities while laying the groundwork for a smooth, progressive adoption of tomorrow's technologies. We will explore how the already deployed LTE can be fine-tuned for utility-specific needs, covering features like release assistance indicator, extended TBS for higher uplink throughputs, and standalone CAT-M deployments. Simultaneously, we'll also look ahead at how utilities can future-proof AMI 2.0 as networks evolve from 4G to 5G and beyond. Ultimately, what I would have to say is success demands ecosystem-wide cooperation, and our discussion today will emphasize that collaboration across spectrum providers, vendors like Nokia, chipset makers, smart meter manufacturers, and most importantly, the utilities is the essential key to a seamless transition. So let's begin. So Ron, maybe we'll begin with you, sir, first. Ron, utilities operate millions of meters with increasingly long life cycles. From your perspective, what are the most critical factors that ensure reliability and resilience in AMI deployments, especially as cellular technologies evolve?
So, yeah, when you start talking about reliability, you've got to have really good, candid conversations with your infrastructure vendors. I think that's something that you have to be aware of. You have to make sure that you have, you know, the right kind of backup. You have to think about aggregation. How are you going to aggregate this large number of sites together so that you can have efficient transport going back to the head ends? I think that, you know, in this case, from Xcel Energy's perspective, we were early adopters. So we started, you know, we deployed a very extensive Wi-Sun mesh, and we started aggregating all this meter traffic to access points that then we leveraged LTE as a backhaul medium in order to bring that in. So that was a huge consideration. And of course, you know, you also have other elements that direct that, but you know, efficiency, quality aggregation, and making sure that you have reliable transport, both primary and secondary, were key considerations.
All right, thank you, Ron. Question for you, Jan. Jan, as an AMI system vendor, how is Itron evolving its smart metering solutions to support the real-world use cases of AMI 2.0, such as outage detection, remote diagnostics, and large-scale restoration?
Yeah, great. Thanks, Hemant. So I'll use a little bit this slide here that we have put up. So first saying, like, you know, grid edge intelligence is really a big theme as part of AMI 2.0, and that is to use meters as sensors and eventually as actuators for grid management, and to allow then a higher overall distribution grid utilization and minimize overload conditions. So that's, you know, in the background, we should always have that in mind, what we're trying to achieve. And to handle those evolving business needs, what we are seeing on the meter side, like AMI 2.0 meters, they combine a very high frequency sampling cycles, like, you know, typically 32 kilohertz now in the latest type of AMI 2.0 meters, with also an pretty extensive application environment. So you can actually create either from system vendors like Itron, or application vendors or utilities themselves can create applications over time that will evolve and adapt the AMI 2.0 system to new needs. So here in this picture, I've classified like two different groups of AMI 2.0 applications that we see today, but this is sort of a snapshot of the ones that are of interest and being discussed and worked on a lot today. And on the left side, you see those that primarily from a networking point of view are client server based. So the central theme is often to get the data up to a server function. It could be the ADMS or other functions in the backend. And on the right side, you see applications that have a lot, we have called it peer-to-peer, but it's saying that there's a lot of traffic patterns where meters and other devices on their same grid components, like transformers, for example, in this here example, need to coordinate and overall give then a view of what's happening on that grid section. One thing to say here also is like some of these applications there on the right are pretty fundamental. So many utilities that we talk with, they see, for example, the grid location awareness being a fundamental foundational application, so that you know exactly where each meter is mapped in terms of transformer, feeder, and phase. So that's to note as well. But that's like the big story. And then you were asking a little bit about what's happening in terms of outage notification and restoration in this world. So I would say when it comes to outage detection, the AMI2O is trying to leverage these high frequency waveforms to actually not only give an outage notification, but actually help with the fault location detection. And the typical approach here is not to send sort of streaming data up to the head end all the time. That would be gigabytes per day of data, but rather do anomaly detection with different signatures on what's happening at the edge, and then send during when you see an anomaly or at the case of an outage, send a few samples of the waveforms up. So it's still bigger data set than the normal outage notifications. So a few kilobytes would be there, and that you would need to map into the network. And for handling that and managing that well, I've also seen that the newer meters that have larger super caps, so you can stay up a little bit longer, those kind of things. And as Hemant was mentioning, we're looking at new cellular features that can also help in that, and we'll go through it. At the restoration side, once the meters come up, it's not like the system level, it's more sector by sector you have to think about, and the load there. And what we have come to conclusion after quite big deployments ourselves on cellular is that you need sort of two timers, like a randomization timer that says like how quickly are they actually trying to get up on the sector to register, and then balance that with a back-off retry timer, so that those two together can build up what you can achieve with the SLA sort of. Okay, I think I stop there. I could talk much more about it, but that's good.
No, thank you, Jan. Further continuing with you, Jan, if you can tell us what are the networking requirements across the spectrum infrastructure and device integration that must be in place to reliably deliver these applications at a large scale for utilities?
Yeah, so you said the bullets first. If we take those first, you have summarizing a little bit what we said. Like the AMI2O is not like the AMI1O use cases have disappeared, which for billing and so on, and outage management. But AMI2O adds sort of this grid edge sensor capability for grid planning and grid management. What we see is that there is a new communication component for that coordination at the edge in order to process and come to conclusions at the edge, and specifically quite a lot related to meters that are on the same transformer. We do see when we have done the traffic modeling an increase in head end traffic. I'm putting here sort of 10x versus an AMI1O deployment, but it can vary depend on application update. But 10x is sort of what we see today if one would take that full scope that we looked on the previous page. I would say some of these, especially when the meter gets to be an actuator and be part of actually acting as well, then predictable latency becomes much more in focus for AMI2O than AMI1O. And you will see that some of the requirements that you have on DA and so on will sort of go towards AMI2O. And in order to act as an actuator, then also there's a new communication component behind the meter, like to actually be able to throttle the EV charge rates and so on behind there. So again, use cases can evolve over time as the utilities see new needs that could be applied and done in my infrastructure. So that top banner there is an interesting one that sort of lists really generally what we look at when you look at large-scale IoT systems and not least for utilities, what are the characteristics that we are looking for, and you can see those 5 there. So the first one is this aspect of no meter left behind, and there are things like what you think of is like if you can run in sub-gigahertz spectrum, it's very good. If you can have higher pyro mode, like you can have, for example, in anteric spectrum, it's very good. And looking at extension options, if that's satellite or a mesh, last mile hop and so on, those are good tools to have. Longevity is always a tricky one because we're balancing technology evolution with rate cases and so on. But also here, there are opportunities, and we'll talk a little bit about that, how for example, LTE Cat M1 can coexist with 5G and try to leverage that. An alternative, have a small layer neighborhood area network at the endpoint level is also another approach. A resilient reliability, there what Ron was saying, battery backups is coming there. I mentioned super caps that are larger on the endpoints, applying QoS, finding redundant paths, applying multi-profile eSIMs. All of those are valid tools and so on there that we look to use. And for scalability, what we have seen is really an important portion to have sort of a network aware headend that actually have separate queues for sectors, device types, message types, and so on. So that in addition to the randomization and backup retries we talked about. And there are some other tools to use there, but we are going to look at some cellular feature that we have explored later on in this presentation that's been interested in. And secured by design, this is fairly complex because it's application level and network level. They both have to go together. You have client server and peer-to-peer traffic that you need also to manage. And all that you need to package in sort of a viewpoint now of zero trust and preparedness for post-quantum cryptography. So those are all going together when you're looking at AMI 2.0 now.
Thank you, Jan, for highlighting all the networking requirements very nicely. Coming to the spectrum, but one thing which I would like to mention that Nokia is central to the success of AMI 2.0 deployments, ensuring that the networks are robust, scalable, and interoperable across diverse devices and different spectrum configurations. And time and again, we have seen Nokia collaborates with a lot of chipset manufacturers, meter vendors, spectrum partners, and this collaborative approach ensures that AMI 2.0 investments are protected as the technology landscape evolves, and utilities can confidently then modernize their networks step by step. With this question for you, Abhinay, spectrum is often described as the foundation for utility connectivity. From your perspective, what are the key challenges and opportunities in aligning the different spectrum choices with the needs of infrastructure vendors and device makers to ensure reliable and long-term AMI deployments?
Thank you, Hemant, and happy to be here on the forum. Spectrum, especially licensed, low-band, standardized spectrum, is indeed a foundation for utility private broadband. Just to go really quickly over the slide, this is the entire spectrum. We are a part of the Band 8, 3GPP Band 8, what in the US we refer to as US Band 8 or FCC 900. As you can see on the bottom in orange, that's the 3x3 megahertz that's licensed for broadband operations for Anterix. Anterix really is dedicated to a long-term roadmap of services and solutions for utility broadband networks, and as a part of that, longevity on 900 was a key factor for us, which is the reason why we embarked on the standardization path. We got by the way, with a lot of help from our technology partners, including those here on the panel, we were able to standardize our band at 3GPP for 5G, 3x3 5G, which is the N106 band, as well as band 106, which is the 4G 3x3. And this was really a huge undertaking, and we're really grateful to all the support from our technology partners. We managed to drive 5G to a less than 5 megahertz to a 3x3 support. Longevity is really the key. Also, I'd like to point out, while 4G is sufficient for most of utility use cases, Anterix is committed to a 5G evolution, and we're ready to support as and when that happens in the future. And all the efforts we're doing is kind of aligning with that messaging. Speaking of AMI, I'd really like to acknowledge again, the work and the efforts by our infrastructure partners and Nokia in specifically, right, where we got really in-band CAT-M operational on a 3x3. This was a huge feature. CAT-M is a foundational technology for AMI, as well as other utility fixed use cases. And what this development, what this achievement made possible was, having an in-band CAT-M channel within the 3x3 LTE. It's an excellent use of resources. You can have dedicated CAT-M inside of the channel for your CAT-M use cases, and the rest of the resources available for LTE or for your other use cases. And really happy that the collaboration between all of us here, between a spectrum provider like Enterix, network through Nokia, chipset and modules from from Sequans, and the eventual AMI solution and systems vendor Icon. That this partnership is what makes this work.
Yep. No. Thank you, Abhinay. Yes, Nokia were the first ones to get in-band CAT-M in 3 MHz. So yes, and then I would further like to add that Nokia has standalone CAT-M, which means it's not dynamic. It's pure standalone CAT-M, full 1.4 MHz being used for CAT-M. We have that feature. We are working on it. It's part of our roadmaps. Yeah. You briefly touched on this topic, Abhinay, but continuing with you further. Next question. Now, as utilities look to future-proof their investments, how can spectrum providers, infrastructure vendors like Nokia, and device manufacturers collaborate more effectively to deliver solutions that are not only interoperable and secure, but also adaptable to evolving technologies like 5G and beyond?
Thank you, Hemant. Yeah, continuing on with the collaboration story, I mean, that's really the key factor across all of this. I mean, from an Enterix standpoint, when band 106 was being introduced late last year and early this year, we had to ensure that there is coexistence between our US band 8 devices and band 106. We had to ensure that any utility operations on US band 8 are not impacted, and really a lot of collaboration and work here between us, device module vendors, and the network vendors like Nokia went into making MFPI a successful use case and a feature that really enabled the coexistence of US band 8 and band 106 devices. On the network side, you had the feature turned on the device side, you have a feature called FGI 31, which is enabled, and that's really the magic sauce that makes this work. And again, I'd like to highlight this as one of the collaborative efforts that actually made this possible.
Yep, no, definitely, because I clearly remember, and I would like to bring this to all the members on the call, that at least Nokia, Sequans, and Enterix, we had an excellent collaborative approach in early part of 2024. I think it was Q1 of 2024 when we first tested the band 106 call on the newly standardized band 106. And then further to augment that, we went on to test MFPI, which we are discussing, which is the multi-frequency band indicator function, and that can help us to coexist the legacy band 8 devices with the new band 106 devices. So they have been thoroughly, vigorously tested in the lab. Regression testings have been done, and we are gradually on the verge of rolling out these features in our utility networks. And further, Abhinay, what I would like to mention is a few days before you mentioned about getting the priority indicator for the map band, which is the band 106. We were talking about getting that band 106 with a certain amount of priority when compared to band 8. Yes, we have those parameters, features available, and we have got that implemented, and we have tested it out. So I think it definitely goes on to speak a lot of, about the collaborative approach that we have. And then you mentioned about, we already spoke, I also spoke about the in-band CAT-M. I touched upon the standalone CAT-M, which is a future roadmap item for us. And then especially in terms of the evolving technologies, what I would further like to add is Nokia was a co-marketer with Anterix, right, for getting the 3 megahertz NR or 5G standardized in N106. And I would say we have a solid partnership in getting the ERED cap also taken across the 3GPP space for further standardization. Question for you, Ron. Thanks, Abhinay. Question for you, Ron. Given the diversity of technologies and vendors in the utility ecosystem, what practical steps can spectrum providers, infrastructure vendors like Nokia, and device manufacturers take to collaborate more effectively and ensure a seamless integration and long-term compatibility of these AMI solutions for the utilities?
Well, Hemant, thank you, Hemant. The first thing that comes to my mind is the fact that collaboration has to be early and often, and it has to be very candid. There needs to be detailed conversations about subjects around MFBI. We, you know, as an operator, we need to understand what that means to us. It means that we can keep our Band 8 devices longer as we migrate toward Band 106. It also opens up the ecosystem to more devices and more solutions and better use case provision to our customers. And all of that comes through active collaboration. We also need to have candid conversations about, where are these devices going to be deployed? What type of environments are they going to be in? How much power are they going to use? How big are they? Will they fit in the current housings that we have deployed? Because now it's a much larger conversation. So if it's great that you have a device with 100 new features, but if it's 3 times as big and I don't have room for it in my cabinet, now I have to look at rehousing that. So then we have to go to the question, do these devices need to be ruggedized in some way so that they're bolt-ons versus just additions to what's already deployed out in the field? Because utilities invariably have to sweat their assets. And in the regulatory environment, we're not allowed to just go pick devices. A new device every now, whenever a new device comes out, we can't necessarily move at the speed of technology. So it's very important that we have longevity and of support for all of these end user devices. And that only comes through really good collaboration and consideration of the requirements of these devices out at the end user locations, especially when you're talking about power, footprint. All of those things are very important, but also making sure that you're either housing it correctly or that you have a ruggedized version of a device so that it can stand up to the elements. I think those are key considerations. I think those are things that kind of help that collaboration be very candid and very focused, so that we don't just assume that the other, we don't need to assume that our vendors know what we need. We need to make sure that we're communicating our needs, and then our vendors need to make sure that they communicate all of the feature sets that are required to support those different use cases and applications. I think those are the important parts of the collaboration piece.
Yep, nicely addressed, sir. We'll touch some of those aspects in the latter part of the webinar. But moving beyond MFBI now, this brings me to a point where I can say that the LTE M ecosystem is quite mature, and I can pass on the confidence to utilities that the system is reliable, offers broad coverage, and supports longer device life cycle. With this question for you, Jan. Jan, CAT-M has been a foundational technology for the utility AMI deployment. From your perspective, what are the key strengths of CAT-M for utilities today, and how do these strengths help address the current operational challenges?
Yeah, thank you. Like on this slide here, you see the different LTE variants here, like from Cat1 to Cat1 bis being a single antenna version, Cat-M, and then Narrowband IoT. And actually, if we look globally, the adoption was a little bit different. So if you look at China and part of Asia, they have picked up Cat1 bis a lot for the kind of endpoint products like metering. And if you look at Europe, for example, they're fairly streamlined AMI use case. They took on narrowband IoT quite a lot. And then in North America, we ended up focusing quite a lot for a balance between performance, cost, longevity on Cat-M. And you can see a little bit of the characteristics of each one of these ones here on this table. And so, Emma, going back to your question about the benefits, I see it is like here we have a Cat-M one. It's right now a pretty mature ecosystem. We have multi-million deployments already in meters with Cat-M. So the early technology risks, most of them have been sort of cleaned up and cleared. And we have actually if we look at modems and so on, a second generation of modems in this area. So it's pretty good and taken care of in that sense. So less risk in that, which is good. And Cat-M, if you look at private and public deployments and combinations of that for handling fill-ins and fallback and so on, the deployments, what I see, going to be fairly similar in technology. Like maybe there will be some features that are enabled on private and not on public, but they're pretty close. So it wouldn't be a shock sort of if you had fallback on a public network in any case, which is good. I think that is deemed for good resilience. The direct head-end connectivity is very good. If we compared with narrowband IoT, in many cases, those deployments have a proxy in between, which is not so pleasant. And overall, like, you know, the higher visibility of each device with direct connectivity is very good. And as I mentioned, you know, Cat-M1 balanced a bit sort of the coverage and speed of the aspects, or generally better coverage than Cat-1 and so on, but better speeds than narrowband IoT. And just for sort of a reference to you, like as we are deploying and Cat-M1 meters and so on, we generally actually use sort of guidelines of don't go below 110 dB RSRP or -5 SINR and so on, like signal noise ratio. Those can sound you know, pretty tough that we put, but that's based on really getting a reliable mass scale of millions of devices. Then you generally shouldn't have all those that are at the typical edge and doing a lot of retransmissions. So the last portion there on dynamic LTE resource allocation, we have actually studied this a bit also in the UVA Plugfest here 2025, and you know, talked a lot with Hemant and Nokia, and it's very efficient, I would say. You know, we are at the millisecond level, where if like a Cat-M1 device is coming up and needs some resources, it gets it, but then releases it to other use cases on LTE. So it's a very positive technology, I would say, and efficient.
All right, thank you, Jan. Continuing. What improvements, Jan, should utilities consider as they seek more advanced features for their deployment?
Yeah, so this actually Hemant and I and Ali at Nokia discussed that for this year's Plugfest. We said, like, what could we take lessons from last year when it comes to capacity and so on, and what are sort of low-hanging fruit actually that exist in the standard and in products but not utilized that can help. So that's what we were out looking for, and the things that we're doing in this year's Plugfest is part of this list here. So first one is actually more related to battery power devices. Most battery power devices we see out there still using something called power saving mode, which is pretty simple. You go to deep sleep and then you come up and wake every few hours and send your data and check if anything to receive. But this additional little bit more advanced capability called extended DRX, that is more or less that you do have your sleep cycles, but you're not sleeping as much, so that you actually have a period where you could receive also network initiated requests like gas disconnects or similar. So we are doing all the profiling of the currents, which leads to power consumptions between these two, as well as between narrowband IoT and Cat-M, and taking into account things like paging cycles that need to be taken care of and so on. And I will not spoil what we're going to show in the Plugfest, but I think we have good results to show, and that will be clarifying these trade-offs. And related to capacity and data rates and so on, we were quite interested in the aspect of release assistant indication, because today in public networks and so on, we let it go to like once we have send our data, we let just the resource on the base station time out, which could be like 5 seconds, and that's almost half of the time we're up. So that's a little bit unnecessary that we hold that data. So release assistance indication, which we have been testing now, actually allows us to explicitly say, like, we don't need that resource to be held for me any longer as an endpoint, and that can be really good for capacity point of view. And I think, Hemant, you mentioned before the extended transfer block size, which associated actually also to higher modulation scheme when you're in good coverage. Those are capabilities that can help overall, but also maybe allow us to move in applications that we offload to Wi-Fi, home Wi-Fi today, like consumer engagements, which is 1 second data, that could actually be mapped for those select users onto cellular. That's one of the ideas. And longevity, I think you will cover more, Hemant, later, but the standalone CAT-M one is a very interesting part of the solutions for having coexistence between 5G and 4G eventually. And I think Ron brought up at least the problem statement on size and ruggedization for new devices. And I talked a little bit with ecosystem here. So, you know, in general, it was difficult when you get with 5G. You have a 4x4 MIMO antenna. That's the trickiest one to fit in the same size. Now, if you go to RedCap, you get you know, 2 antennas, and if you go to CAT-M one, you get to 1 antenna. You can also think about using multi-profile eSIM instead of multiple SIM card slots and so on. So there are possibilities there, and I think the what I understood, the ecosystem for example, DA gateways and so on, are really working to try to keep the size and ruggedization level as the legacy. It depends a little bit on, you know, everything of what is the legacy interface and so on to be sorted, but both RedCap and CAT-M one helps at least on the antenna side. But more on this, Hemant, will be at UBB Plugfest.
Yes, and then further to add, Jan, for these features, extended TBS or the release assistance indicator for higher capacities, they have been thoroughly tested in the past 2-3 months. And then what I would just like to add is we'll show all those results when we meet during the Plugfest, and then we'll get to show all these functionalities working live during the Plugfest. Yeah. So thank you, Jan. Jeremy, question for you, sir. LTE-M and CAT-M have reached a certain level of maturity in the ecosystem. From your perspective, how is the chipset and module landscape evolving to support the AMI 2.0 cases? And if you can maybe further add what enhancements are emerging today and how they might influence the utility's ability to deploy, upgrade, and future-proof their metering infrastructure.
Right. Okay. Thanks, Hemant. Thanks for this question, and thanks for having me on this great panel. So, talking about maturity, yes, we did launch our first fully optimized LTE-M platform back in 2016. So today we have our 2nd generation Monarch 2, which is mature, proven, shipping in volume, notably in the utility space. And while we are already working on the 3rd generation and not only supporting CAT-M1, but also future standard like 5G and our RedCap that we'll talk about later, we keep enhancing our Monarch 2 platform to support an increasingly number of AMI 2.0 use cases. So as Jan was pointing out, we try to push battery usage even further, using features like release assistance indication, extended TBS, relaxed monitoring, also trying to bring more flexibility and more ruggedization and size reduction using eSIM with multiple profiles that can be configured both during manufacturing and also post-deployment, supporting also public and private LTE to give as much flexibility as possible. And all of this, as you both said, will be showcased at UBBA PlugFest in November. And also because we own as chipset and module maker the technology at the chipset level, we can also help customers tuning and adapting their solution for utilities. So there's always room for optimization for utilities, for specific use cases. And when we're talking to you guys, understanding what AMI 2.0 is all about, what Ron needs, what Jan needs, we're trying to help tuning these solutions to make sure that we have a good fit for all of these use cases, adding new bands like what we did for band 106 for private LTE usage, and securing all the needed certifications, being regulatory or operator certification, or making sure that the utilities get what they need at the end of the day. And all of this can only happen with close collaborations with carriers, utilities, spectrum owners, key customers, and infra partners. So we are a single ecosystem, and this is what we're trying to show here with this panel today. So the result of that is that CAT-M1 is, has the right maturity and stands out as a technology that can also bring some longevity for tomorrow, because we're still leveraging and enabling new features specifically for the utilities. Now, and we can move to the next slide, please, Hemant.
Yep.
On top of CAT-M1, 5G is coming. Whether we want it or not, it's been around for a few years already in the smartphone business. We've had smartphones supporting 5G ever since, for the past 5 years, starting 2020. And soon we have 2 new versions of 5G and R that start addressing the IoT space. I'm talking about RedCap, that stands for reduced capability, and eRedCap, standing for enhanced reduced capability, which goes further down into addressing the IoT needs with more cost-reduced solution and leaner solutions that eventually replace whatever we have today with LTE. They both operate, RedCap and eRedCap, on fully standalone networks. RedCap is already here. We've had public announcement in the US from both T-Mobile and AT&T of nationwide availability of RedCap. So yes, the migration from 4G to 5G has begun, and it starts addressing the IoT space. It will also take time. We started seeing demo and trial on RedCap back in 2023. We just start seeing nationwide deployment, and we're also expecting, and pricing of RedCap is still a bit expensive today for the modules. So the technology, by the time we start seeing massive adoption, we're expecting it's going to be like in 2027. So we need to anticipate this migration. We also need to acknowledge the fact that it's not happening today. So we just need to prepare and anticipate. And as technology providers like Nokia or Sequence, we obviously need to make sure that all the bricks and everything is getting ready. eRedCap, we're also expecting taking an extra 2 years compared to RedCap to be ready, more like late 2029, early 2030, to start being massively adopted with the right price point and right level of maturity. So if you're asking for advice for utilities, we need to continue optimizing what we have today. We need to fine-tune spectrum usage, network configuration to improve power efficiency, capacity, resilience, security, redundancy. And we also need to preserve the flexibility to upgrade devices and network over time. because in our space, telecommunication in utility space, the evolution is not happening overnight. It's engineered, so we need to make it happen, and this is where collaboration is key.
All right. Thanks, Jeremy. Yeah, one thing which I would like to add is smarter grid isn't just built in a single leap. It's built step by step, technology by technology. So yes, Jeremy, you touched it. We'll cover it in the next slide as well. E-RED-CAP, I think, is one of those key steps, which is complementing the LTE-M of today while paving the way for future's 5G-enabled utility. Jeremy, continuing with you, while E-RED-CAP chipsets are just beginning to emerge and there are still many unknowns, what should utilities and ecosystem partners be aware of as they plan for this transition? If you can quickly try to cover it up, sir.
Try to make it quick because it's already 45 past the hour.
Yes.
So yeah, we have this slide that tries and explains the different variants. You see RED-CAP, E-RED-CAP, CAT-M, Narrowband IoT. So as to have references of existing technologies versus new technologies, and the bottom graph tries to express the transition from LTE to 5G technologies. Like E-RED-CAP is kind of in between Cat1, Cat1bis, and Cat-M as an evolutionary capability for IoT. It's replacing Cat1bis and a bit of Cat-M, and RED-CAP is more on the higher end. So we announced earlier this year our commitment and funding to develop E-RED-CAP chipset. The project is moving full speed, and what we're seeing is indeed E-RED-CAP will come together with Cat1bis, LTE-M, and Narrowband IoT to have a full technology portfolio to serve the IoT utility space. And all of these technologies will coexist for several years. Focusing on E-RED-CAP, so it's indeed a new 3GPP standard coming with release 18, modified with release 19, which are not deployed yet. So we need to make sure together as an ecosystem to have these kind of discussions, making sure we're aligning on the feature set, configuration, so that when E-RED-CAP is arriving, we don't have any technology fragmentation. All of us, when we talk about E-RED-CAP, that should be a unique version of E-RED-CAP. So that whenever Jan Itron is deploying in the US with Excel, or in Europe with a European utility, with a European operator, the configuration can be the same, so that we can have economy of scale and make sure that solutions are harmonized with the right level of performance. So yes, but there's also big value on E-RED-CAP, so that's something that we need to keep in mind, because it brings the most recent 3GPP standard, so it's a good foundation for future evolution for AMI 2.0. And this is what we have on the right-hand side. With E-RED-CAP, we have long-term support, obviously, because that's the new technology compared to LTE-M or Cat1bis. So any new capability can be brought in together with E-RED-CAP, can be factored in from the start of when the technology is being deployed. And we have several of them, like reduced signaling overhead, small data transmission, which are optimized in terms of power consumption. We can do as well network slicing, so we can have a dedicated 5G slice for utilities, for example, for critical application, which gives priority, which is something that we don't necessarily have today with 4G. So there are new things which justify the value of E-RED-CAP moving forward. We need to know that it's not what we have today, but it's a standardization body that can be used to bring in new stuff, so that when we're moving forward in the 2030s and 2040s, we know that we can have better stuff than what we have today.
Yep. All right. Thanks, Jeremy. Abhinay, quickly coming to you, and if you can answer this briefly, What risks do the utilities face if AMI 2.0 needs are not represented in the ongoing 3GPP efforts, and how can an early engagement help?
From an Enteric standpoint, we are keeping track of all these new technologies on the horizon. Jeremy just went through a lot of it with RedCap, the evolution to RedCap, and now we see in release 18 eRedCap. What we're doing is ensuring that our spectrum is capable of supporting these new technologies, and we keep working on the standardization part to ensure our these technologies are supported. Even as of last month in September, we introduced a new work item at 3GPP, essentially addressing RedCap and eRedCap, both support for 3x3, and we are extremely glad that this was supported by a lot of our technology partners, including everyone here on the panel, and that's how we keep track of any new developments. We see Cat-M going to be around for a long time in terms of longevity, but we are also making sure as as the future evolution occurs, as things go to 5G in the future, we are well positioned from a spectrum standpoint to support RedCap and eRedCap.
Right. Thanks, Abhinay. Yes. So as we touched upon before, in-band Cat-M, okay, were the first ones. There is a petition submitted already for getting the Enteric spectrum to 5x5. In-band Cat-M with that 5x5 is not an issue. As I mentioned, we are the first ones to work on the standalone Cat-M, which means it will be 1.4 megahertz being used. We don't need to have an in-band LTE to host the Cat-M cell. So it will be a standalone Cat-M. So it could be 2 standalone Cat-Ms. It could be LTE with an in-band Cat-M in 3 megahertz. Further talking about 5, if you see this combination, 3 plus 1.4, we could always have 2 Cat-Ms, one in-band and then one standalone Cat-M. It could be 3 megahertz LTE with standalone, or we spoke about RedCap, eRedCap. So it's not an issue. We could easily have 3 and then a standalone Cat-M. So it's all investment well justified. We don't need to completely shut down Cat-M. Cat-M will be the mainstay. It's going to stay. It will be in a standalone flavor, and then we could always evolve our 3 megahertz to 5G. And over and above, what I would just like to summarize is any combination listed here is all software configurable. There's no need to change anything related to the hardware. All these possible combinations, and there could be even beyond. We are talking about 3 plus 1.4. We could even sneak in a couple of NB-IoT channels depending on the need. So we could use the full 5. So all of this is software configurable, nothing needed on the hardware. Yeah, let's keep at least 5 minutes for the questions. I think we have very short time to a couple of minutes to drive this conclusion now. Ron, quickly coming to you, how has this collaboration with technology partners like us, spectrum partners, and device and meter vendors helped you in getting a more reliable and future-ready solution for XL?
Well, as my esteemed colleagues have summarized very well, we're constantly trying to put 10 pounds of data in a 5-pound bag. And this collaboration has helped do a couple of things. Alleviate a couple of risk issues, like will technology outpace my ability to deploy? Spectrum congestion. I need to know that my partners are working with me to make sure that I don't run up against the congestion wall with regard to spectrum, and that I have a path to expand my offering to my internal customers. Also, security is also this huge issue. I can't keep old technology in my network. I have to have the ability to quickly and seamlessly move to newer platforms and newer infrastructure in order to keep my customers safe, in order to keep my security, my level of security very high, and keep our customers and our business units safe. So you can't say enough about the importance of collaboration with vendors. You can't put a price on it. It's only through collaboration with our spectrum infrastructure, end user, chipset vendors. It's only through this really collaborative environment that we will be able to do everything that we're being tasked to do.
Yep. Abhinay, your thoughts?
Thanks, Hemant. Yeah, I mean, again, spectrum, licensed spectrum, low band spectrum, standardized spectrum, it's really the invisible foundation, right? That's basis for utility private broadband. And really, if you think about it, it delivers real value when devices, networks, and utility use cases are actually designed to operate over it. And on this panel here, using AMI as a use case, we have the entire end-to-end ecosystem from spectrum to utility operations to devices, modules to the network, and that's how we collaboratively make sure we bring a use case to life and operate it. Eventually, all of us here have an end goal, which is really the transformation of the energy grid. We want to make the modern grid that's stronger, that's secure, that's smarter, and that's resilient, right? And this end goal cannot be achieved in a vacuum.
Thank you. Jan, concluding comments from a smart metering perspective before we go to Jeremy.
Yeah, no, very good comments already. I would just say, like, our experience over time here that we have been working in this space is that better to work, this best and critical to work directly with where the source of knowledge and technology is. So that's why we work very much with modem chipset vendors directly. So we can work with Sequans and so on that. We have worked very closely, in the past with and so far with mobile operators, like direct contact, be able to resolve things and so on. And maybe one step away, but to the infrastructure vendors. But now with private cellular, I think we're going to get a much closer direct collaboration there. And because there are things always coming, both in operations where there might need to be updates in either components, and being able to escalate and resolve that as quickly as possible is important. And just an example, I think we updated most of a carrier network recently based upon what we actually saw and so on in field. So this kind of close collaboration that one can act quickly is very important.
All right, thank you, Jeremy. I'll cut you, sir. Let's take a couple of questions. Sorry, Jeremy. Bobby, if you don't mind, if you can maybe let us know if there are a few questions, and then maybe we can take a couple.
Actually, you covered the two questions that were asked, so I would like to go back to Jeremy and let him give his closing thoughts, because you covered them in your comments just now. So beautiful.
And as part of my closing thoughts was really about appreciating the fact that one way of sharing our collective experience and enhancing whatever we're doing, because not a single company can build the future of connectivity alone, is the value of industry forums like the UBBA. So thanks to you, Bobby, to enable us to have this kind of discussions together, not only doing webinars, but doing the PlugFest event that we have next month. This is really valuable. And I'm not saying it here because you're in the call, but I mean it. And it's been a way for all of us to talk together so that a chipset or module vendor doesn't only talk to a device maker like Itron. We also talk to Nokia, we also talk to Anterix, you also talk to Ron. And this is where you bring a lot of value. And so thanks to you.
Thank you for that. Final word from you, Hemant.
No, I think together we can shape up the connected utility of the future. And if there are any questions, please reach out to any one of us. We are tightly coupled. anything happening in the utility space related to AMI 2.0 or in general, we are all tag team together, and we will for sure shape up a better future for the utilities. I would, to conclude, I would like to thank everyone on the panel, you, Bobby, and UBBA, and then all the industry colleagues that joined us on the webinar today. Thank you.
Thank you, Hemant. And I will say to the audience, bring your questions to the event in November and talk to these guys firsthand, because these are the guys who are going to be helping you answer all of those questions. Great questions. Great webinar today, guys. Thank you so much. We'll say bye-bye for now, but we will see you all again very soon. Thank you from UBBA and from all of our members. Have a great day. Be safe.
Thanks,
Thank
Bobby.
you.
Yep.
Bye.